Okay, so this little business summary I thought I would do would be it's a little bit about data types and types of data. So it kind of really follows on from the previous business summaries. The book, again, there's a couple of pages where it discusses data types as kind of the intro to the book. So really this is just, sorry, the intro to the chapter. So this is really just, expanding it a little bit and talking a little bit about different types of data. As usual, as this isn't kind of apart from the first few slides directly related to the exam. I'll try and keep this brief around 30 minutes or so. Okay, so this kind of chapter is almost like the introduction to statistics. And the purpose of this chapter is we are using kind of descriptive methods. So we're maybe using tables, summary statistics, and I would say in order to gain some sort of insight into the data. We take a data set, we maybe find some averages, we maybe look a little bit at the variation in manufacturing processes. We may see, for example, how variables, change related to the averages. So we're really just kind of summarizing the data a little bit. But to do this, we need to measure. And so this little summary is very much about measurement. And in physical sciences, measurement is very easy. We talk a lot about, we've got miles, we've got kilograms, we've got time. These are all kind of physical metrics that we can measure quite easily. But it's a little bit different, say, in marketing research. How do we measure customer satisfaction? How do we measure customer happiness? So if we've got a business data set, we may have things that are maybe slightly more difficult to measure. And that's where this kind of defining measurement levels of the data come in. So let's just kind of go through the book definition. The metric is the actual unit of measurement. So this could be a time in seconds. It could be a single tick on a scale, how much do you like this product from 0 to 10? Measurement, we're actually measuring the thing. So maybe we're using a stopwatch or a modern version of it for time. Or maybe we are running a little kind of survey where we ask consumers about their satisfaction. And the measures are the values that we get from our measurement. So kind of very straightforward. Now, we've got we're thinking at the moment about quite simple types of data. And I want to give a few business examples later on in this discussion where we talk about maybe more complex types of unstructured data. But we have discrete. So, for example, if I was to ask you, you have to have customer satisfaction 1, 2, 3, 4, or 5, that would be discrete. If I give you like a little sliding scale where you can kind of have any point between 1 and 5, you could have, say, for example, 1.322221, then that would be much closer to continuous. Now, there is a little bit of a gray area in this. Quite often, for example, if I had, the amount purchased, say, the number of products purchased, that's kind of discrete. But in most cases, I would probably treat it as continuous. And the same if I have a customer satisfaction score from 1 to 10, again, that might want to treat that as continuous. But I'll try to start off by giving you kind of some examples. So the first measurement scale we'll talk about is the categorical scale. And this is basically just categorical data that is not ordered. So we could have things like gender. We could have things like ethnic group. What we couldn't have is something like an order. So we couldn't have, for example, in this class, you would get an A, B, C, D, or an F. That would be categorical data, but it would be ordered. Now, let me just kind of give some examples of nominal data. So this was from when I taught marketing research. Indicate your marital status. Do you dislike or dislike chocolate ice cream? That's a binary variable. You've got a true or a false. Now, binary is a special case. In some cases, you may want to treat it as having an order, but generally it's considered nominal data. Which of the following supermarkets have you shopped at in the last 30 days? And again, please indicate your gender. This is probably maybe a little bit out of date. Maybe you would put some non-binary, maybe you would put other. So the next little example is ordinal data. So this is measurement scales where we can order things. So let's just have a look at ordinal data. And the first question, it's asking you to give your kind of preferences. So you would like rank these. So this is a ranking. A ranking is an ordinal scale. So we're ranking methods of different banking. So I would put number 1 inside the bank, 2 drive-up windows, 3 banking by telephone, etc., etc. So we have some sort of an order. Second question, which one of these statements best describes your opinion of the quality of the PC? And here you can see we've got kind of an ordinal category here. We've got higher, about the same, and lower. So we can say that higher is the highest, about the same is the middle, and lower is the lowest. And the third one is for each pair of retail discount scores, circle one store that you would most likely to shop at. And again, this would be kind of, you would summarize this table and you would probably get some sort of ordering, maybe Target first, then Kmart, then Walmart. Those are examples of kind of quite pure ordinal scale data. So the next, and this is where a little bit of maybe controversy comes in terms of different types of measurement, is interval scale data. The kind of the definition is it's kind of continuous, but we have arbitrary 0 points. So this is not a time where we have a real 0, because in time, 2 seconds is twice as high as 1 second. The classic example given for interval data is temperature, in that the 0 for most scales, unless we're dealing with Kelvin, doesn't have any real physical significance. So you can't really say, for example, that 20 degrees Fahrenheit is twice 10 degrees Fahrenheit. That doesn't really make any sense, but it is a continuous measure. But the 0 is kind of arbitrary. So that's interval data. Now, this is kind of, I've put this here because I mean, this in the book I got this from, this was actually an example of, they used it as an example of interval scale data. Now, I'd say this data is not purely interval scale data because it's not completely continuous, but generally people would actually utilize this data as kind of interval scale data. So here we are. How likely are you to recommend a certain restaurant from 1 to 7? Again, the 0 is kind of not meaningful. You can't say 2 is twice as much as 1 here. It's just a scale of recommends. We've got 0 to 10, highly satisfied, and 0 being not satisfied at all. But again, even though 0 is not really satisfied, you can't say 2 is twice as satisfied as 1. And here we kind of have a multi-attribute scale of never used to use very often. So that really isn't pure interval scale data. It's probably kind of somewhere on the border, somewhere on the cusp of that. Okay, so going backwards a little bit. Our final example is ratio data, and ratio data is anything, I've not given any specific examples, but anything continuous or natural zero. So the length and time a customer takes to respond to a promotion is continuous data. How far someone drives in an average week, that would be continuous data. So that's kind of pretty much self-explanatory. Now let's just kind of give a few examples of some more kind of business examples. So this is kind of an example of a Likert scale. And a Likert scale is basically kind of a 1 to 5 or a 1 to 7 scale. It could be satisfaction. And generally, we would give it certain kind of textual kind of quantifiers. So here we're going from very dissatisfied to very satisfied. We could have, for example, very unlikely to repurchase to very likely to repurchase. Now, there's all sorts of like theory behind Likert scales, which is probably a little bit beyond the scope of this class. You know, it's like, do we have a neutral category? How many points do we have on the scale? And quite often, what you would do sometimes with Likert scale data, if you have 10 very similar questions, you would add up the results into something called a summated rating scale, and then treat that summated rating scale as continuous. So this is a little bit more, I think you might do a little bit more of this in your marketing classes, but this is just one way of measuring kind of survey data. So here's another fun little example. Again, it's like a Likert scale, and here we're kind of on a scale of 1 to 5. And we've got different attributes here for different supermarkets: clean, dirty, bright, dark, low quality, high quality. And you would kind of actually draw a line for each supermarket. And again, we'd get kind of an ordinal value for each of these attributes for each supermarket. Another kind of example of almost like Likert scales. These are kind of graphical scales. And the idea, again, is that sometimes consumers will have more of a kind of a visceral kind of response to scales. So just something like a smiley face can often be as equally as effective as having a kind of a textual Likert scale. And here we're kind of combining them. We've got the strongly disagree to strongly agree Likert scale, and illustrating this with a smiley face. So if we're maybe surveying kids, I've seen this as an example of nations where there's a high degree of illiteracy using these sort of scales. But this is kind of just a graphical Likert scale. Here's another example. This is from a survey. This is just what I gave before, the rank order scale, where we rank different attributes, and again, to get an ordinal value. It's important if we do something like this that we have some sort of initial randomization, because there'll be a heavy bias for the initial kind of starting categories. And this is an example, and this is my example of a ratio scale in an actual survey. I talked about ratio data in terms of like speed, time, length, but what we're doing here is we're saying you have percentage of time that you spend performing various activities at your home. Please enter a percentage for each question below. Your total must equal 100. And what we're doing is we're splitting up this 100% of time or 100% of effort into kind of manageable blocks. So here again, based on the customer service, distribute the rating out of 100, kind of in terms of these different attributes. So this is a way of getting, and again, it's not probably, you're probably going to use whole numbers, so it's probably not, you're not going to put 19.99999, but it's as close as possible as what you can get to kind of continuous data. And particularly in the first example, as this is like an actual time, then this would be ratio scale data. Okay, so this was kind of, I thought this tied into my question last time, and as some of you summarized, the film was Napoleon Dynamite, and I talked a little bit about recommender systems. And I actually found the original. This is actually an interesting article. This talks all about the competition, if you've got access to New York Times, and the Napoleon Dynamite problem. And basically, what this does, these recommender systems do, is obviously they're much more complex these days, but they do utilize correlations between items. For example, if Hostel 1 has very similar review patterns to Hostel 2, then if somebody likes Hostel 1, we're going to try and recommend them Hostel 2. And if user 1 has very similar review patterns to user 2, if user 2 has seen a film that they liked, I'm liable to recommend it to user 1. So that's just kind of recommendation systems. And one of the interesting things is that in the book, you'll see we cover basic correlation. We use something called Pearson's correlation, continuous correlation. There are correlations available for ordinal data, but we just assume the data are continuous because most of these reviews, even though they're not completely continuous, they're kind of almost continuous. And there's generally even distances between 1 star, 2 star, 3 star, 4 star, and 5 star reviews. And I think what happens is that you lose a little bit of accuracy for using the wrong type of correlation, but this is less than what you lose for losing some information and treating this data as ordinal. So essentially, when we're dealing with this sort of data, we just need to be pragmatic in a business sense. We don't have to think, whoa, this is really ordinal data. We shouldn't be treating it as continuous. So here's just some examples of online reviews. Online reviews, single scale online reviews, the Amazon reviews that we all know and love. And this is from ratebeer.com. And this is kind of multi-attribute reviews. Here we're reviewing our beers. This was actually from one of my favorite English beers on 5 different characteristics. This is aroma, appearance, flavor, mouthfeel. I don't know how you actually rate the mouthfeel of a beer, and then the overall ranking is summated from those 4 kind of sub-rankings. And I guess it's then converted into kind of a star rating there. So that's kind of a multi-attribute review. So here's an interesting example. This is where we have an ordinal scale, but we convert it to continuous. So this was actually traditionally used by Nielsen marketing research firm, in that based on past research and follow-up from consumer panels, we have a scale that measures propensity to use a product, and then we convert it into an actual probability of using the product. And then based on past purchase data, we actually convert it into a predicted purchase. So then we can use this survey to maybe predict purchase volumes and do calculations on, whether we want to introduce a new product or not. So we have some maybe pre-testing. We give a survey on whether we'd use the product, and then we convert it into actual purchase intent. That was interesting, going from kind of an ordinal to an actual ratio scale data. Okay, so here's a little summary based on the material in the class of what we've done, and then I'll go into some more complicated data. If we have nominal data, if we have categories, the only measure of central tendency we can really use is actually the mode. It doesn't make sense to find, the middle value for, for example, categories of major. We can't say finance is greater than accounting, is greater than marketing, etc. So the most kind of appropriate measure for nominal data, or the only appropriate measure of nominal data, is the mode. And we can't use the median, and we can't use the mean. Now, for ordinal data, we can still use the mode. We can still say, for example, the most common grade is a B, or the most common grade is an A, but it's more appropriate to use the median grade. We could say the median grade in the class is a B, or the median, if we have satisfied, neutral, and unsatisfied, we could say the median satisfaction is neutral. Now, generally, it's inappropriate to use a mean for ordinal data, But if we have numbered ordinal data, for example, consumer reviews, as I just noted with my Napoleon Dynamite example, then, or Netflix example, then people generally do it anyway. And then both interval and ratio scale data, we can still calculate the mode. If we have something like seconds and we go to like a high degree of granularity, like 0.3346 seconds, then the mode is pretty much kind of meaningless, but we can calculate the mode and the median for interval and ratio scale data. But generally, we would utilize the mean. Now, it's the same for measures of dispersion. For nominal data, we just, we have the histogram. We just have the frequency distribution that has the highest point, which is the mode. For ordinal scale data, we can actually calculate a range. So we could say that, we have a satisfaction scale of 1 to 7. We could say the highest satisfaction was a 6 and the lowest was a 2. That would make sense. Though we can't really, and again, with this kind of online review, people tend to do this anyway, but the most appropriate method would be the range. And for kind of continuous data, then we can still have a frequency distribution where we put things in bins. We can still calculate a range, but the most appropriate metrics are the standard deviations. Okay, so to summarize, we've gone through some simple data types. We've talked about nominal, ordinal, interval, and ratio data. And we just kind of gave some examples of how these data are used in practice. And then we just finished off by relating it to the work in the chapter on kind of central tendency and measures of dispersion. But modern data can be quite complicated. We can have, for example, data in social networks. We can have unstructured data with text, images, all sorts of different videos, all sorts of different things. So I just want to kind of finish off by giving a few examples of more complicated data. So we have here some social network data. Now, social network data and the analysis of that data is becoming increasingly more important. You have someone on a social network, you have their friends, you have their friends' friends. From a business perspective, we could use it, for example, to analyze communities of interest. For example, on a social network, we may have a community of people into a certain hobby, such as geocaching, who may have a certain political affiliation. And then we can kind of target that network. We can look at kind of individual metrics. We can look at, how influential people are. Do people kind of forward my posts or retweet them if it was Twitter? Do people follow me? Do people like my posts? If I kind of recommend a product, do people go out and buy that product? So there's lots of different kind of, data metrics we can gain from social networks. So here's another fun example, and this was a social network of, and this was derived from Twitter, of what people were following and posting on. And these are different kind of news sources. And I think this was designed to analyze kind of political polarization. So we have all these kind of we have the right-wing news sources, we have the left-wing news sources. We're looking at kind of links, there might be somebody who shared the left-wing Huffington Post and the right-wing Breitbart, but that's kind of unlikely. So this was kind of a look at political polarization in this very kind of complicated social network. And we can see here that, for example, we've got Fox News and Breitbart on the right, CNN, Huffington Post, New York Times, Washington Post on the left. And then we have this political site, The Hill, in the middle of this. Okay, this is an example I've talked about in one of my marketing classes. And this is, I thought this was kind of quite interesting because it's an example of, quite advanced social network marketing, but in a developing nation. And this was an Indian ice cream chain, which allowed users, called Hokey Pokey, which allowed users to test and, create their own kind of custom ice cream flavors. And the idea, what happened here is this was a social media marketing campaign. So the company monitored social media conversations. They identified influential people. Um, they looked at some of the characteristics of these influential people, and they used this to identify influencers. These were influencers recruited. In this instance, they were kind of given a free custom ice cream, and then when they were asked to post that ice cream on their social media account, and then these people were incentivized maybe with coupons, cashback, etc., to post these custom ice cream flavors and to recommend the ice cream shop. Now, the idea is somebody was influential and people would follow them and say, whoa, I love that ice cream. And then I would actually go out myself and purchase my custom ice cream from that shop. So what's kind of quite interesting with respect to this chapter is we're actually converting social network data into kind of more traditional numeric data. So for this, the customer influence effect was calculated. And this is basically, the proportion. If I send out a message, it's almost like the proportion of people who like the message or in Twitter retweet the message. There's a lot of people on social media who just send out a lot of information, but it's not particularly influential. So if 70% of my posts are retweeted by B, then my influence on B is 0.7, etc. So we looked at this example, looked at the customer influence effect, and it looked at the stickiness index, which is the topic of conversation. For example, I think Kim Kardashian is a relatively influential social media influencer, but she's probably not going to be, she doesn't really talk about tech and analytics and tech products. So if I wanted to advertise a specific tech product or software platform, then she might not be the ideal influencer because she would have a low stickiness index. And again, this is the customer influence value, very similar to the customer influence effect. If I promote something and then people see this and buy the product, what sort of revenue comes from my influence? So this would be the customer influence value. So this was kind of a nice example of taking a complex social network and finding some interesting metrics from it. My second little example of kind of unstructured data is of text data. Text data is used quite a lot. We have online reviews, we have blog posts, we have people, complaining on Twitter about bad customer service. So it makes an idea that we might be able to want to analyze this data. We might want to know if somebody's writing a review of my product, say on Twitter, where there's no kind of actual star score, we might want to work out if it's negative or positive. We might want to work out whether somebody's angry or not. We may want to kind of classify this information. We may want to, for example, look at, and we can often do this by looking at the syntax of the document. So we may want to work out, is this a news story? Or is this just simply, a customer complaint or something? We may want to look at how, basic metrics such as word counts. We may want to actually, I'll show you an example of something I created called a word cloud, where we look at kind of, which specific terms are used in which specific documents. So I'll start off with a little bit of an example. And this is a sentiment analysis using IBM Text Analytics. So let me fire up the browser. I'll just stop that in a minute. Now this is an example, and this was like a commercial example, but I've programmed some text analysis applications using R and Python. But this is IBM Watson, and it's quite a complicated API where you can actually put in text, for example, of reviews or documents and analyze these documents. But they do include a very simple demo on a web page. And it's actually, we were talking about clouds last week. This is part of the IBM cloud. So what you can do is you can enter some text and then analyze this text. Now, I actually have some text. I did some analysis of online reviews on Yelp, and I was like looking at different types of sentiment, and I've actually got different documents. I've got one which has lots of angry reviews. And this is a very angry review about the Shed Aquarium in Chicago. And I don't know how people could get so angry about an aquarium, but this person obviously hated the aquarium. If you just look at this review, it's kind of very, very angry. So we'll just go down and through this very angry review of somebody who was like incredibly angry about the Shed Aquarium. And let's just enter it in the text. And click Analyze. And you can see here that the overall sentiment is very strongly negative. We can see that there was some joy there. Maybe there was a joy of being angry, but there was disgust, anger, sadness, and fear. These were the keywords extracted. And again, this could be, yeah, we won't go down too far on that. This could be used in further analysis. Kind of almost, I talked about semantics and syntax and semantics. This is just kind of the major kind of nouns of that were mentioned. So we have the shed, and again, this is not perfect. The shed is not a person. Categories, where how this is actually categorized, and a little bit of the semantics. And again, this is a little bit out of scope, but you can see this is actually quite a deep analysis of this text. So let's kind of go back to my slides. So here's another example. This is one I did in my predictive analytics course. So yeah, Reddit actually has, if you've come across Reddit, but it has a Reddit called Random Acts of Pizza. And what people do is they kind of give a plea of why they deserve free pizza. I've been laid off from my job. I've lost my apartment. I really deserve a pizza. So here's some examples of some of the requests. And I actually did some sentiment analysis on this. So I looked at, relating, whether people were ultimately awarded a pizza. Would it be better if they gave like, I'm angry at the world sort of plea, or, I'm happy sort of plea, looking at what sort of plea would actually result in a free pizza. But I also kind of did a little word crowd here where we kind of looked at the most common words and combinations of words, or what's called bigrams, for A, not being rewarded a pizza, and B, being awarded a pizza. So not being awarded a pizza, if you just say, I asked for a pizza, you're unlikely to be awarded a pizza. Things like time, college, leave, starving, just general things. More likely to be awarded a pizza. I guess this is if you actually give an image of yourself or give some sort of like thing. If things like pay forward, you give me a pizza, I'll give someone else a pizza, that would be more likely to get you the pizza. So this was just a very simple example. It's not a brilliant example of a word cloud. And we're just looking at the different kind of major words used for people who got pizza and people who didn't get pizza. Okay, so that kind of just pretty much wraps up today. It was, again, I just wanted to go through, expand some of the material on the book on different measurement types, and also kind of tell you, hey, there is some gray area here, particularly between ordinal and interval. You will find that, data are very rarely completely measured continuously. There's usually like maybe integer data, or scale data 1 to 10. So it's not a given. There is some gray area there, and talked about some examples of these different types of data. Then we talked a little bit about the summary statistics you can use in these types of data. And finally, we just gave a few little simple examples of modern unstructured data. I talked a little bit about social network data, and also a little bit about unstructured textual data. I gave you an example of sentiment analysis, and then some analysis I did on the random access